Today we're going to learn about solving radical equations. A radical equation is an equation that has a radical. It can have a square root, it can have a cube root, and so forth. Your goal to solve a radical equation is to isolate the radical. So what I tell my students to do is just to think the radical as a big giant x. So think of this as x minus 1 equals 3. How would you get that big giant x by itself? You would add 1 to both sides, right? So that's what we're going to do here to isolate the radical. I'm going to add 1 to both sides of this equation, and then I get the square root of x plus 5 is equal to 4. Once you isolate the radical, now you want to get rid of it. Remember the index on this radical, because it's a square root, remember there's an invisible 2 here. So what we can do to get rid of the square root is square it. And then remember, whatever you do one side of the equation, you got to do to the other side. So you want to square both sides of this equation. What happens is this square and the square root cancels out. And you just get x plus 5 on this side. And then 4 squared is 4 times 4, which is 16. So now you just solve it like a normal equation. So now subtract 5 from both sides, and we get x is equal to 11. And it's important on these to check your answer. So the last step I want you to do now is go back and check your answer. So you're going to take your equation, you're going to rewrite it, but what you're going to do is you're going to replace the x with 11, whatever answer you found x to be. We found x to be 11 on this particular problem. So substitute 11 in for x, and then see if the left side equals the right side. Are these two statements true? Well, 11 plus 5 is 16. So we get the square root of 16, which is 4, and then minus 1, which is equal to 3. That's what it's supposed to equal. So this is the solution. X equals 11. All right, let's try another one here. It says solve the given radical equation. If you notice, this equation has a cube root, but you do it the same way. Okay? So you want to think of this radical as a big giant x. So think of it as 2x plus 5 is equal to 15. So how would you solve this equation that's written in green? Well, it's a two-step equation. You would have to subtract 5, right? And then you got 2x equals 10, and then divide by 2. Okay, so that's how many steps it's going to take to get the radical by itself. So we have to subtract 5 first, and then divide by 2. So we're trying to isolate the radical. So I'm going to subtract 5 from both sides of this equation. So now I get 2 times the cube root of x plus 1 is equal to 10. And again, we're trying to get the square root, actually the cube root by itself. Think of it as a big giant x. We want to get that big giant x by itself. So we got to get rid of the 2 that's in front of it. So we're going to have to divide both sides by 2. These 2's cancel out. So now we have the cube root of x plus 1 is equal to 5. On the first one, we had a square root, so we squared both sides. This one, we have a cube root. So the index is a 3. So to get rid of the cube root, you cube both sides. So these are going to cancel out. So now you have x plus 1 is equal to 5 cubed. So 5 times 5 times 5, so 125. Then subtract 1 on both sides, you get x is equal to 124. And then just like on the first one, I want you to check your answer. So go back and plug in 124 for x. So I'm going to rewrite this again. equation, but instead of having x, I'm substituting 124 in place of it. Everything else stays the same. I want to know, does this equal 15? Okay? So we're going to work under a radical first. We have 2 times the cube root of something. 124 plus 1 is 125. Now we're going to do the cube root of 125. The cube root of 125 is 5. Now we got 2 times 5 plus 5. 2 times 5 is 10, plus 5 equals 15, which was what it was supposed to equal. So the solution is x equals 124.